Today I'm going to talk about regulator parts, how they work. We'll go talk about how the devices, what they do, if there is some troubleshooting with the part, and a lot of common issues I've seen in regulators doing maintenance on them. In the first part series, we're going to talk about the GE. Then we'll have a second part talking about the Siemens, and then the third part would be over the Cooper regulators. All right, the first one I'm going to talk about is the GE regulator. This is the internal parts of a GE regulator. One of the biggest things that I see happen is the gears actually break. So there's jagged teeth right here, and this rod will just free spin. And you can actually hear that because the motor will still run, but the gears will not make a tap change because it just free spins right there. To replace it, you got to remove the cotter pin here. There's a dry pin right there. Pull that out, and then replace it with a new gear, and then it should be good to go. Position hands, usually this is not an issue, but if your hands are not moving, this could be a part of your problem. So down here it's connected again to the gearbox. Goes to a drive shaft in the back of the head, which makes your taps change from step 1, step 2, whatever the change is. Biggest problem in a regulator is a capacitor. A capacitor helps drive your raise and lower function in your control. A lot of people move these to the control box. They're easier access to get to. Most regulator manufacturers already have this done in new regulators. But if you have old regulators just like this one, the capacitor is inside the tank. If you have a couple of extra wires inside this control cable going to your control box, you can actually move the capacitor outside depending on wiring configurations. Last one is the neutral light switch. If you are not having a neutral light on the control, it could be the control, but it also could be right there. That's the contact for it. So that could be an issue inside of the tank if you don't have a neutral light. The GE regulator, they have an arrestor inside the tank for added protection, and then obviously there's a motor. The motor actually is fused on the control as well. So the fuse could go bad on the control, but that would also mean that the motor's bad as well. The control box can't handle the load that's coming through the regulator, so it has to have something to step down. So they have a current transformer which steps down the load going to the control, and the potential transformer as well steps down the voltage. Okay, this is the picture of the primitive auto. I'll talk about more of it in the next slide and what it does. And then you also have the utility winding. So utility winding basically has leads that go to each stationary contact that changes the voltage for your downline member. Okay, I'm going to talk about the reversing switch and the movable contacts. They kind of go hand in hand together. On the reversing switch, whenever it moves from one location to the other, right now it's over here, it can move over there. That's whenever you have the movable contacts here and here. They'll go counterclockwise or clockwise, depending if it's a raise or lower. If you go counterclockwise, they actually raise, and if you go clockwise, it actually lowers the voltage. So on the movable contacts in the previous slide, I talked about the primitive auto, which would be one contact here, one contact here. Obviously, you have a difference in potential and voltage, and that's where the primitive auto helps with the bridging factor, and that's on every odd step. So each bridging part is always an odd step. When it's together, it's a neutral. If it's together here, There's 2 of them here. That would be step 2 plus 2. So again, if you're going counterclockwise, your hands would actually go clockwise. So it's opposite of each other on the hands compared to the mech. So I hope this helps with the GE regulator, and I'll be doing 2 more slides over the Siemens and the Cooper. Thanks.